Hey, you're back in the garage with TheEZGZ. And today I got a bunch of things to share with you. Wait! You know, in my videos I always say, wait, there's more. I want to answer some questions that have been left in the comment section, as well as show you some things that I've been analyzing on my own that I think are important. And right off the bat, let's get into it. It comes to the point here. I'm going to use a stock camshaft, and that's no big deal. Putting together a stock Volkswagen engine with stock parts is like putting your shoes on in the morning, in my humble opinion. As long as you have a book, as long as you have a feeler gauge, as long as you have some basic tools, you should be able to take an engine apart and put one back together. Now, these cases, like I said in that last video, they're like old socks. They get worn, and depends on what you're going to do with it. If you buy a new case from a reputable company, there's a chance that you'll be able to use a standard crank, standard bearings, and stock cam, and it should just go right together, okay? But in this case, I'm driving myself nuts with all this extra data, and it's really kind of fun. I've never done this before. So at any rate, I think that what's really got me going here is the fact that I'm using a stock cam, and it's like, okay, how can I get a little bit more out of this engine with a stock cam? The main thing for horsepower, there is no replacement for displacement. It doesn't make any difference how you get there, boring it, stroking it, and we all argue about, you know, what's going to give more torque, you know, a short connecting rod, a long connecting rod, a short stroke, long stroke, 94 cylinders, 95, 92s, 85, you know, there's so much more to the engineering, and basically none of us are engineers. We're back engineering this. We're taking something that's reliable and proven and that's been out there for years. And I've been involved with my neighbor across the street. He's working on a Model A. And so I had to brush up on my old Model A stuff. I used to have a 1930 Model A pickup when I was, I think I was 31 years old. And I'd never got it finished, but I did get the motor running. And I hung out with the older generation back then. And I wanted to make a hot rod, but I didn't have any money. But yet I had all the parts to make the stock car work and function, so I thought I'd start off with that. And so now this work across the street, I've been doing some research and looking at some stuff on the YouTube, and you know, Scat, the company that makes our one of our better crankshafts for our replacement crankshafts for our Volkswagens, they make a forged counterweighted crankshaft for those old Model A cars, and they said something at the end of it that we want to support the 300,000 Model A folks that are still out there. I thought to myself, yeah, you know, you have to have a market before it's worthwhile. It doesn't do you any good to produce things one at a time. You know, you have to have like a setup and a production run. That's the only way you're going to make money, is to mass produce something and not have to go painstaking one step at a time. And I am doing the opposite of that. I am doing everything, and I'm looking at everything, because once I close this engine up, you know, it's going to be running for a while. So I want to make sure that I don't miss any little details. One of the things that comes to mind, I don't know if you guys have ever heard of Formula V. It's like a Formula 1 race car with open wheels, single seat, little car, race car, and they have very strict class rules about the engine and so on and so forth. There's an example of some guys that will look at camshafts and they'll measure a whole bunch of camshafts. You can buy, I think Webcam makes what they call a Formula V camshaft, which is the stock dimensions, but it's $150. If you want to get the normal stock cam, just you know, a run-of-the-mill cam, it's like 75 bucks. So it's twice as much to just get a few thousandths of an inch more accuracy on that camshaft. You see what I'm saying here? So this is kind of the driving force behind my line of thinking here, and I'm just having fun with this. So what's the deal here? A few years back, I had bought this cheater cam from CB Performance, and I ended up not using it. I used an FK7 cam without using the ratio rocker arms, and it worked just fine. And so I have this cam left, and I've been fighting with myself as to whether or not to put it in. But I told you guys that I was going to build a stock cam single port 1776, so I think I feel like I need to do that and follow through for you, because this particular build has aroused a lot more interest than I ever thought it would. So, okay. When I bought that cam, I didn't get lifters for it. I bought these MP Lubalobe lifters, okay? And here they are right here. If you look just off center, there's a little dot. That's the dot. That's the Lubalobe. That's what this is about. Now see, if you look through there, man, that thing is so small. I don't even know if I have a drill bit that small. I do not think, and it's been said, that it's just going to cause you to lose oil pressure because you've got too much spill off. Now, whether that's true or not, I have no idea, but that thing looks pretty harmless here, you know? I think you could get more spill off the side of one connecting rod than you could from that little tiny hole. But the reason I didn't use it was because of this large bowl in the bottom that holds your push rod. And here, let's take basically a stock push rod and stick it down in there. And, you know, it feels, you're supposed to have 6/1000 clearance when that's at rest. And I'm having trouble when I compare it to these other lifters. This one's awful filthy. That's one I'm not going to use. I just pulled it out to weigh it. I'll show you that in a couple minutes. But that seems more of a pocket. See? It just seems more of a pocket to hold it there. So if you are going for that 6/1000, it's not falling down. Because our lifters and push rods are horizontal. So I just thought that might just chafe the end of it. If anybody has any experience with these MP one-piece Lubalobe lifters, please put it in the comments section below, because I just, you know, they're so difficult to get to. I hate to experiment, you know. Maybe I will on another engine on another time, but I thought, you know, with the zinc being missing from the common oils, I thought maybe that's the answers. Just get some lubricant directly on the cam lobe. Now that I've done more research, I believe that we need the zinc. It really does something for the surfaces. Modern engines use roller rockers and different types of setups, shim and bucket, all kinds of different overhead cam type situations. So the flat tappet cam design isn't the same. You know, even the LS Chevy motors, I don't know if they're using a flat tappet like this. It's not like this, but you know, those things get incredible horsepower and RPM out of them. So at any rate, let's kind of do something here, just for giggles, okay? We're gonna zero out our scale, okay? And we're gonna take a bone stock lifter and we're gonna put it on there. 97 grams, okay? 97. You don't have to write it down. I got it over here on the board. We're going over there to next. The next one is this, what they call the ultralight lightweight lifter by CB Performance, and it's 75 grams. 74. Lift it off. 74 from 97 is 22, and that's what they advertise. It's a 3-piece lifter held together. It's got a snap ring in there. Oh, I'm getting ahead of myself here. Now let's go to that MP Lubelobe lifter. That is 92. Now this is a one-piece lifter, okay? There's nothing underneath that cup, but it comes in at 93. 92, there it is. Sometimes you have to let these scales settle out. Maybe it's my hot breath, okay? It's going back and forth, it's borderline. This is a one-piece lifter. The CB Performance one is a three-piece lifter. The stock lifter, there, if you look, I took something out, these things were filthy, I wanted to clean them up, and I poked something down that hole in the side and was moving it around, and I couldn't see it from the top, and I thought, what's going on here? And indeed, this top cup is pushed down, but to keep it from collapsing, they put a piece of round stock. They didn't put a ball, because they didn't want to put a ball bearing in there and have it clog the oil hole. This is the oil inlet. Well, more on that later, okay? Now, I think we got one more to do here. We got a reground lifter. And that's coming in at 86. Now, this is a stock Volkswagen lifter, but it's been reground. So it's like 10 grams lighter than a bone stock new or used lifter, because they have to regrind the surface, and when you do that, you're grinding away some weight. Okay, makes sense? Does to me. So I've always seen reground lifters. I never tried them on this build. That's what I'm going to do. Stock cam, reground lifters, and these are lighter than stock. I'm interested in keeping a very light valve train. But I don't want to get off subject yet. Not yet. Okay, here you can see half of my engine crankcase. And I want to tell you that I use these silver line camshaft bearings. These are double thrust bearings. I spent hours working these things to get my end play. It didn't even want to fit. Now this isn't the stock cam that I'm going to use, but I finally got just that little bit. Just that little bit. I just wanted a little bit, just a thousandth or two clearance on that thing. You couldn't even turn it. It felt like you had it pinched and somebody was holding it with their hand. You couldn't turn it. And it took me a long time. I didn't want to go too far. Now, these bearings, they're smooth shell. The oil comes around the back. This side of the case is the passenger side of the case, okay? The passenger side of the engine, all right? Which would be the right side, because you always say right and left according to how you're sitting behind the steering wheel. So this is the right side of the engine. You'll note that this is the suction side of the oil pump. How does the oil get to the lifters on this side of the engine? All the passages are on the left side of the engine. They're not on this side. Well, they cross over and it goes through this little square right here, comes up through the base, and it crosses over, goes down, comes from the other side, coming this way, and it crosses over there, comes down to the passage, and you can see there's a hole right there. They drill this all the way through. They drill it from the back side, and then they plug it. They drill it all the way to this last lifter bore. There was some, I'm not even going to go there. There was some mod that you could extend that and pick up some extra oil, but we don't even want to go there. I tried it on a case and it did not work. But it was a junk case anyhow. And this was years ago. So, you've got your oil, you've got your bearings, you've got your lifters. The oil, as your lifter sits down inside, it's being pushed up against the cam by the spring. And it's not that far off of there. Maybe we should put it in and you can look at that too. How about that? Now this is what is this? An Engel 100. I just was using this to mock things up. It's handy, but it'll make my point. Except you have to put the lifter in first. Okay? And you want that to be a tight fit. Not so tight that it can't turn. It's got to move freely. But if you put the cam lobe there, and now we're going to look underneath that. See, it's laying. Gravity's holding that thing down. And this is only like a 400 thousandths lift cam. Stock is about 315. Well, look what you get here. You know, it's multiplied at the rocker arm with the 1.1 or 1.25, 1.3, 1.4, whatever you got. But stock is 1.1 on the 1600s. So if you use an extreme camshaft, you have to be careful that you have enough room. These lifter boards are beveled, but sometimes you have to get a tool in there to allow a higher lift cam lobe to push that lifter farther down. And when that happens, it throws the timing off of that lifter board. Okay? The oil hole. And this is why this little mod, God, that's an ugly one. This is on the empty Lubilobe. I did this years ago and never used it. There's one. You'll see guys say, oh yeah, I put this little groove in here. It makes for better oiling. The reason was it was lifting so far that it wasn't getting in the second oil loop. Now, as you look down here, you know that these have a dome on them, don't you? These are not flat. They're not, convex is going in or out, concave is going in. These are dished out, just barely enough to see any light in there. Now, the idea is every time it comes by, it's going to just minutely rotate that lifter so that it doesn't sit in one spot and wash the oil out. It's constantly moving, it's getting replenished with oil, the oil hole's moving around, but that galley that goes through there, that oil port, needs to cross over and it needs to get into all of these lifters and lubricate it. Now in a Volkswagen, the camshaft is underneath the crankshaft, and there's so much spill off from the connecting rods, the mains, and all this sort of stuff, plus just general turbulence in there, that you don't need anything else to lubricate the cam lobes. And so the thought was, with the Lubilobe, you're going to put it directly right there close to the contact point. Now, somebody left a comment, said the reason why they came out with these type of lifters was that on American V8 engines, the lifters are above the crankshaft. And so this is a more direct way. They don't have oil falling up, even though there's stuff getting flung all over the place when all engines are being operated. Okay, so let's go over here to my little board. If your engine tachometer is idling at 1,000 RPM, your camshaft is turning half that speed. So it's turning 500 RPM. RPM is revolutions per minute. So if you take the revolutions per minute, a minute has 60 seconds, divide that by 60 seconds, that means that valve is opening and closing. Doesn't make any difference whether it's the intake or the exhaust. They are out of sequence. It is a 4-stroke engine, so it goes intake, compression, power, and exhaust, but at that half speed, it's 8 times a second. Okay? So now if you're going 2,000 RPM, your camshaft is going 1,000. It's 16 times, 25 times, 41 times. At 6,000 RPM, you'd be doing 50 times a second. Now, you can't just have this stuff bouncing around and smacking off of these things and letting your valve float is when the camshaft comes by, there's a space between the lobe, and it throws that lifter clear out here, and then when it does
move a little bit further, it smacks back down on the side. That destroys things. That's like a little hammer in there hammering away. And it's hard on your valve seats, it's hard on the whole thing. But what you're looking at here, most factory stock 1600s or Volkswagen based engines are capable of 4 to 4500 RPM. Now, you can over rev it if you're in a VW bus and you miss a downshift and you're going downhill and you got all that weight and you start pushing your engine, you can over rev it and that will break parts. That's where you have problems and you can break parts. You can do it in a sedan. That just seems to be a good example. So if what is opening and closing the valve and the valve train, which includes the lifter, the push rod, it has to go through the rocker arm and come back down. It's the spring. So these springs, it's important. If you want an engine that's going to turn high RPM, you have to have more spring pressure. And you can't get that high RPM with a stock camshaft, basically, when you're pulling under load. So you put in a competition camshaft. It gives you more horsepower, but it happens at a higher RPM. It lifts the valve higher and maybe keeps it open longer. And that's how you get more fuel in, and that's how you get more horsepower. But everything is happening quicker. And so you need more valve spring pressure. You have an old Volkswagen. People always are asking me, what I'm going to rebuild my engine. What can I do for a little bit more power? You don't have to do anything. Just rebuild your engine and you're going to have a lot more power than you have right now. Just because the advertised horsepower of a 1972 VW 1600 dual port was 60 horsepower or whatever you read in whatever book you've got, that doesn't mean all engines have that. And if you're not running oil with zinc in it or running some sort of an additive in it, this doesn't happen in one drive, although it can. If you don't have, on a fresh rebuild, if you haven't done things right, and you haven't broken in the cam right, you can have degradation fairly quickly. You will know that because after it cools off and you go to drain the oil and check the valves, you're going to have a lot of clearance. If your rebuild went well and you've drained the oil, let the engine cool down, and your valve clearance haven't changed or have changed very little, then you're probably okay. But you know, these things get old, there's valve clatter, people aren't using good oil, they have so many leaks, they figure, yeah, I don't need to change the oil, I just keep adding it, and I'm getting all those good additives. Well, you know what? All that foreign matter from parts inside your engine, in addition to the carbon, is moving around just like sandpaper and just slowly grinding things away, and the power gradually goes away as well. So I really think, you know, these cars wouldn't have sold if you went to the dealer and test drove a new car and it didn't just scoot along down the road and keep up with everybody else and go the speed limit. People wouldn't have bought all the millions of them that they did. It was a great car for its time. So if you have an old engine and you're thinking about using those original valve springs, I caution you to measure the pressure of your springs. And you know, it only takes 1 out of the 8 to have bad pressure, and it's going to affect the way your car runs and idles and the smoothness of it. If you don't have even if you've had your engine balanced, if you haven't paid attention to those valve springs, it could affect it in a way to make it always feel like there's just a vibration or something there, okay? So one of the ways to improve the overall RPM and to give you a quick, fast reacting engine, especially if you're adding dual carbs or a dual carbs and adding a mechanical advanced distributor, your engine's going to rev quicker. You put a Lighten flywheel on it, we do all these things, it revs quicker, it responds quicker, and it's important to have those valves follow that camshaft profile. So another thing that you want to look at, here's some stock aluminum Volkswagen push rods. 39. Okay, that's a 1600 base push rod. Now here's another. Looks like it's stock. This one is only 30. It's 9 grams left, and I haven't even cleaned the inside of it out yet. This is from an older engine. This is from that 1300 engine over there. It had 77 cylinders, but it also had smaller valve heads, and Volkswagen used, you know, smaller diameter rods. The whole idea here is you only use as much material as you need to get the job done, because it adds up. You take 10 grams for every what would it be? If it's 10 grams difference, for every 4 of these, you could have gotten one of these free. You see what I'm saying? Now in the lifters, we're just trying to keep the weight down. The stock lifters, 97. The CB 74. The MP Lubalobe is 92. The Reground was 86. So you save 10 grams there. You save another 9 grams here. And that starts adding up. And okay, so let's just say, how much is 22 grams? Just to give you an idea, you can do this at home. I decided what's something that everybody's got, and these aren't, these are, I'm not sure what kind of quarters these are. They might be some of those aluminum ones. They got the right heads, but they've got some of that goofy stuff. That looks like an older one. But just generally speaking, that's close enough. 23 grams, 4 quarters. Now, here's what I want you to think about. Those 4 quarters, if you hold them together in your hand, it feels like something, you know? Now, multiply that. You're trying to make that go up and down probably 25 times a second. Those 4 quarters, that's a lot of energy right there. So if you can reduce that energy, you can extend your RPM range, and you can, weight adds up. Now, some people will say, don't use heavy-duty springs, don't use double springs, don't use triple springs, because it uses horsepower. Well, if you're at the track, that doesn't really make any difference. You know, a supercharger on a car takes horsepower to operate a supercharger, and that costs you horsepower, but you still come away with a lot more horsepower. My Ford Lightning has an extra 100 horsepower because it has a supercharger. Okay, if you have a turbocharger, that's another way to gain horsepower, and a lot of people say, well, it's free because you're using spent exhaust gases to turn the pump to get more air in there, and to a degree, you know, that's an accurate way of doing it. But you add complexity to it, you're adding heat to it, there's other issues that come along with that. Now, with the steel straight cut cam gears, they say it takes less energy to use a straight cut gear, and you know, you save some weight. They usually always have them full of holes, so that's a way, because as you're speeding it up, you're turning it. When you put a Lighten flywheel on it, it allows you to spin your engine quicker, and that's what you're trying to do. If you're interested in just acceleration, now it might make it a little bit more difficult for your grandmother or your daughter who is 16 years old learning to drive, because they're not real good with the clutch left, because that inertia that you get with the heavier flywheel helps you start out, okay? So those are some things I want you to think about. Now, look at the end here. Now this is, how far did we get? We got the 39 and the 30. Here's a common chromoly push rod, 39 and 30. Here's a stock length chromoly push rod. It's 70. So you saved 20 grams by going with the ultralight lifters. But now, if you put the chrome moly push rod in, because you have heavy duty springs, and sometimes what happens with heavy duty springs, it will bend the aluminum push rod. Sometimes this steel tip will get drive it down in there. It will crack or squedge or bulge inside there, and you know, those are all things that lead to you're going to be parked on the side of the road. This is a Geenberg May West End stock length push rod, and it's 61. So it's 9 grams lighter than this one over here. And I'll tell you, I've seen some chromoly push rods, guys, made out of pipe. They weighed a ton. So, okay, we're coming back to the work is being done by this spring. And we know that if you have too much pressure, what the key point is here is to have just enough pressure to do the job at hand. And stock works just fine. If you're just constantly over revving it, if you have a bus or you're very low gears like that, or you're going off-road where your engine's getting revved because you got oversized tires and things, you know, completely stock engine with heavy duty single springs might not be a bad way to go, but it's going to cost you a fraction, you know, a little bit of horsepower. And I know this to be true because when I would set the timing, adjust the valves on my 2110 and I was running the double springs, you know, it was hard to turn that engine over 180 degrees. It felt, wow, I got a lot of compression. But what I was feeling in addition to the compression was the spring pressure of 2 springs in there. And we're not going to go into too deep on that. Now, I've got this green box here. I had bought these shims from Geenberg years ago. I bought a bag of 100 of them. And what they're for is, here's a stock head just sitting on the bench. And this is where a stock, have I got a stock spring here? I was supposed to have a bag full of springs. Oh, they're right here. Okay. Here's a stock spring. Now, if you look at a stock spring, they're closer at one end than the other. And that's the way they made them. It helps stabilize the spring. Now, when you start adding spring tension and increasing the RPM, springs, if you've ever watched a video, do a YouTube search. There's some, I think it was CSU, Colorado State University, that did some slow motion tests on springs, and it is wild how these things start boogieing around at high RPM. You start getting 5,000-6,000 RPMs, you get the weirdest distortion. Part of the reason you run a double springs is not so you get not just that you get additional spring pressure, but the inner spring stabilizes the outer spring, and you do develop a little bit of extra heat there, and so on and so forth. So what you do, if you've got a spring, you don't want to be chewing down here into the head itself and having that aluminum floating around in your engine. So what you do is you take one of these steel washers and you drop it down over that. And any place that sells valve tools and valve equipment and valves and springs probably has it. Some of the better Volkswagen suppliers may mention it in their catalog, but you might have to do some searching. Like I said, I got these from Geenberg when I first started doing all of this stuff, and you see where it just drops down there. Now I've got 2 different sizes. When I was going with the double springs, you cut away some of it, and you've got 2 springs in there, so you needed this wider piece. If you take apart an engine, you may see these copper pieces of copper here. This is will be laying in there. I've seen different things. I've pulled apart heads and taken the springs and stuff out of them, and I've seen stuff made out of different materials laying there. Now, if you've got this little wafer, you know, those lines aren't there just for looks. That's supposed to be the bottom side that sets down, and sometimes these things will be stuck to the head. I don't know why they use it. It says right on there, this side up, but that's to keep it from turning, because your valve spring with stock rocker arms. Now remember, if you look in your book, it always says to get that stock valve spring adjuster off center. And what they wanted to do was to keep rotating that valve. We don't do that anymore. We don't have sodium-filled valves on replacement heads. Anytime you rebuild a Volkswagen head, even if it looks good, it's a good idea if you got more than 20,000 miles on it to replace the exhaust valves. They're only like less than $10 a piece, and you need, what, 4 of them? So that's just insurance, because you don't want those things coming apart. It just ruins your day, let me tell you that. So, and I've never had that happen, but I'd like to think that I don't have to do everything the hard way. So that's my take on that. And let's see, what else can I tell you here? What else can I tell you? All right, somebody was asking me, what do you do with these camshafts? How do you clearance the camshaft when you're using a performance camshaft and you bolt the cam gear to it? How do you get clearance between the nut and the back of the oil pump? Well, here's one example right here. You get a cam gear that is already cut down. I happen to have a special tool that I can do this myself, but this one was purchased that way, and this came off of something else, and it's just a lightened aluminum one. Okay, now somebody else wanted to see, I was complaining about my new cam gear having all these rough edges on it, and they wanted to see how I was going to smooth that out. And I did it over here, just holding it up against the wheel, and I'm going to insert a little bit of that action right now. Let's see, here is a straight cut cam gear that is perfectly good, served me well, and it was steel on the crankshaft. It wasn't cast iron, it was steel, and this one was aluminum. It wasn't as noisy as the steel on steel, and I don't see anybody selling these anymore, and I don't think this had any really that much wear, and you could advance or retard your timing. This was something I purchased from Gene Berg. I put on his 295 cam. I ran it in a 1776 per his recommendations. This was a rebuild motor, and I was running at about under 6-to-1 compression with that hot little cam and double springs, and that thing worked so good. The first time I took it out, the pressure plate slipped. The clutch slipped in first, second, and third gear. Anytime you stepped on the gas, the engine would just rev. It did hold in fourth gear, but it didn't in the lower gears, so I had to put in a Kennedy stage 1, and that screwed up my balance because I had it balanced with the other pressure plate. But I ran it that way for just years and years and years. You can see the widened slots, and you can see the effort that they went to, even with those steel washers in here. Let's do the old weight thing, okay? Here's a stock 343 for basically stock aluminum gear. 303, so that's 40 grams less by lightening it up here, and that's rotating mass. That's all of that stuff to the average person doesn't make any difference. But if you're just looking for that little edge to beat your friends and to know inside your head that you did it, is so much fun and is so satisfying to me. I mean, that's the fun of this. You have options. You don't have to do it the same as everybody else. You can do things at home in a home garage and get results and make a difference. They will tell you that heavy duty oil pumps, if you go bigger than the stock 26, if you go with the 30, some of them are 36 and even bigger than that, those steel milling pumps, that's costing you horsepower, and you really don't need that kind of a oil pressure unless you're spinning 10 pounds per 1,000 RPM, that's the old rule. So if you're turning at 8,000 RPM and you need 80 pounds of oil pressure, you may want to do that. But that kind of an engine is the kind of engine that's only going to be run for 15 seconds at a shot. Those steel oil pumps always dribble, always leak because they don't expand at the same rate that the case does. These factory aluminum pumps, they work just fine. One of the guys asked me about these index marks. I'm embarrassed to actually show you this mess here. If you look at this this pump right here, you see these little dots on the cam gear. What does that mean? What is it for? Well, I looked and looked and looked, and the only thing that I could come up with is if you're reusing a pump or it was made this way, that you want that index mark on the same side. If you were to take the gear out, and they come right out, you know. If you were to put it in, flip it over the other way, and it's worn itself in the previous way, then you might get more oil pressure, you might get less. Now, this is the one I'm going to use with the filter set up over here. Here's an oil pump. Now, I want you to look at the inside of this oil pump. Look at what I did here. This is a 26 millimeter oil pump, and I was using it full flow, so I tapped the pump and I put in a brass plug. I had to put a slot in there so I could screw it down. You can see the end of it down inside here, and it actually looks like it was off of I don't know why that has that hole there. Mostly they just have the one on the bottom, but for some reason I did not use it. Now this one does not have the index marks, but I want to show you, and I've made videos on this on an oil pump video. See how I widened that hole out? I massaged it over to the side to give it the ability to pull more oil through the same size hole. That's a performance tip that was in that old How to Hot Rod Volkswagen magazine, and I just, you know, I tried it. I'll tell you one thing, whether it works or not, I have no idea, but when you go to pull this pump out, your standard oil pump puller doesn't have anything to grab onto on that side because you've taken away, and it's really difficult to get those pumps in and out. Oh, look at the back of that. Here's a perfect example of somebody that didn't clearance this. His initials might have been GZ. Easy Jeezy. I don't know. Maybe I did. Or maybe something got some. But you can obviously see where the bolts of the cam gear were hitting the back of the oil pump there. Gosh. And then you've got that aluminum. You know, it's good to have a magnet on your oil filter or on your drain plug, but a magnet's not going to pick up that aluminum, and then it's going to get sucked back through your pump, and maybe that's what caused some of those scratches there. Let's take this. Oh, here's another thing too. This pump came off of this engine here. I cleaned it up on the wire wheel just a little bit. I almost can't get that. I did that and the gasket still didn't come off. And I want you to look at how that groove in there is filled up with gasket sealer. And the purpose of that groove being there, let's see, does this pump have one? Yeah, look at that. Okay, the purpose of this groove around here, you notice there's a little line, and this is the suction side of the pump. So what the deal is, and here it is again on this one too. The idea of that is you're supposed to lay your thin gasket on there, and if you do have any oil leakage and it's moving this direction, all that oil is being scavenged back to the suction side of the pump. Suck is suck. It don't know where it's coming from. It's not pushing out, it's sucking in. So it's trying to take that oil that's trying to escape and bring it back and suck it in. By putting gobs of you know what, who knows what on there and plugging that up, you're preventing that from happening, and I guarantee you'll probably have a leak anyhow. And sometimes it's a good idea to put a little sealer by your studs coming out of the case to stop that down. And they have those nuts with the little rubber seal on them. You put them on backwards. It looks like a nylock nut, and you put it on backwards. They don't come in the kits, but I've seen them, and that's supposed to help eliminate some of the drip and dribble that comes off of a Volkswagen. So let's take this one, and here's the hole, and it would center up here into, it centers on the camshaft, that slot in the end of the camshaft. And they make two different kinds. This is a 3-rivet cam, known as a early style. And then they have a 4-rivet cam, which is a late style. It's more dished. When they came out with this 26mm pump, this is a 21mm pump. This is the smaller gear. And it fits in this hole, and it goes back. And when I turn it, there, it dropped in because it's in the slot. So you have to make sure that you get that in the slot. Can you hear that? There's supposed to be a little bit of free play in there, and there's not much room. This is the 21mm gear. Now, you see the rivet there? Can you see down inside there? There's not a lot of space, and that's where I was chewing on that thing. So, when you put in a 26mm pump housing, let's take this one over here. Yeah, this one is the one that looked like it was rubbing. So if you're using an aftermarket cam and you have to add the cam gear yourself and you're not riveting it, you're going to drill it and tap it and use bolts on it, and you put this in here and you're checking it for clearance. Okay, now what happened to our what happened to our clearance here? Oh my gosh! You know, this one's been clearance, and that's just a rivet. So, in addition to countersinking your bolt head, like I did here, you may also have to grind off the top of the bolt itself, the head of the bolt. And you do want to use some sort of a star washer, and you do want to use Loctite on that. You don't have to worry about centering, because it gets down here in the recess. But, those are some things that people asked about that I wanted to make sure that I got them some answers on that. Generally, on the bigger pumps, they actually the pump kind of protrudes out this way. Although, when you compare these two, doesn't it look like this smaller 21 gear pump looks to be like it had a bigger flange on it this way. It's pulled out where this one's actually recessed in. So that's probably why I had the problem. Let's see if one of these others does it. Here's just for giggles. Now this is the CB Performance one. I don't know what we're going to be able to see here. This is the new one. Okay, that goes in there. Let me get my light. This is an old case. 1300, but it's okay for this example. Oh my gosh. That's a tight fit, folks. That's a real tight fit. Yeah, look down in there. See the gears? See how that works? And what I did was took the edge off, that corner off, and it allows the gears to suck oil all the way across without having to turn a corner. Now, all that stuff, radiusing things that instead of having a 90, now this one here, I'm probably going to go right in here. Where was that? Doot, 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 doot. Right there, comes back in there. I'm probably just going to round that corner, although it doesn't look like I need to. I already massaged this thing a little bit, but I wanted that hole to be a close match to the hole in the case because there's a difference here. So I opened up that case hole in my last video, and I showed you all about that. I won't redo that again. Now, here's something that was interesting as well. Now, on this early case, which I think may have been rebuilt, No, this is only one thrust bearing. I looked at these cam bearings and I said, now look at that wear mark and look in the middle. I can feel a groove right there. That cam bearing was made that way, and I think this is, I don't know where these bearings come from. This one's got the thrust on both sides, and usually one half does. When you buy these Silverline bearings, the double thrust type bearings, it has that double thrust on both sides. Now this is going to have a stock cam with stock springs. You know, I had it in stock, so I thought this time I'm going to go ahead and use it, and it's there. Doesn't hurt anything, and you know, I don't know, might just cost a little bit more in the long run, but I thought that was interesting. I think this is a better bearing than the newer ones. So now you see all the discoloration, you see all the burnt oil, everything gunked up and stuck. Obviously somebody wasn't changing the oil at regular intervals. I suspect that this thing was rebuilt because I measured the case has, and it looks like it was cut first over, but I can't even feel the wear. I can't feel that with, I can barely feel it with my fingertip. It just, I would reuse that if it wasn't for this doggone, look how badly that is eaten away. Isn't that a shame? Water got down, and this thing just sat for years and years. So yeah, I hate to just trash the case, but we're gonna see how these single relief cases work when I get done with this one. If I'm having oil pressure issues, I just might bone up and buy myself a brand new dual relief case. I'm using the Silverline cam bearings. I'm also using Silverline main bearings because they have the steel backed in them. There are also all aluminum bearings available. And, you know, just if it gives you any peace of mind whatsoever, those Model A engines are a lot less horsepower, but they are doing away with Babbitt bearings and using these aluminum inserts, and they say they can get 400,000 miles out of them. But you're talking an engine that only puts out, you know, less than 40 horsepower and doesn't get driven that much. So I was watching some videos on bearings and the function of bearings. It was at the SEMA trade show, and I thought, oh, this is interesting. I want to hear what this guy has to say. It was King Bearings, so I don't know, you could do a search yourself and hear what this guy has to say. I was totally fascinated about his explanation of main bearings and connecting rod bearings on engines. I thought, you know, it's the old principle of a hard material and a soft material. Now these do have steel backing in them. This is a magnesium case, and they do pound out the cases, and that's why you have to have them line bored. There's the pin that holds it and so forth. And I thought, okay, so what's the deal on these bearings? When you take apart an engine and you see all this stuff in here, okay, that's foreign matter. Part of the job of the main bearing is to absorb the foreign matter. If you get a big chunk of something in there and it sticks up, it's going to start grinding into the crank journals. But many times you'll see a bearing like this and the crank journal doesn't look too bad. Matter of fact, I think this one came off of this crankshaft, I just want to say. And you can see how bad the journal is, the bearing, but the journal itself doesn't look too bad. Those are reflections over there, those horizontal lines. And yeah, another thing I noticed, so all these things come to mind. This is a stock Volkswagen crankshaft with welded on counterweights. But when you look at stock Volkswagens and you look at expensive crankshafts, they'll have this slot cut in here. Some of the cheaper aftermarket crankshafts will just have a hole. And I want you to know the purpose of that thing is right there. Again, we're coming back to the old oil. You see these oil troughs right here in this bearing. Well, I thought to myself, okay, this is to spread out the oil, you know. But guess what? In this form right here, it seems like it's doing it wrong. It's turning clockwise. And I thought to myself, well, wait a minute. It should be going counterclockwise so that the oil that comes out the hole spreads over the bearing, right? And it kind of smooshes it out there, kind of like a squeegee, right? Bah, wrong. This trough, yes, this does turn to the right. It does turn that direction. And the reason it's set up like this is so that as the oil that's in the bearing, in the main bearing, it comes along here, it kind of fills it up, and all of a sudden it stops, it's interrupted here, all of a sudden, bloop, it pushes the oil down that hole. That's how your connecting rods are getting oiled, from your main bearings, right? Did you ever think about that? Yeah, your oil gets to the crankshaft by coming up through the back of the bearing in that hole in the case. How can I show you this? Okay, you see these oil holes? These are from the main oil galley. These are how your main bearings get the oil. It goes behind the oil. It goes in this groove that's in the back of that bearing. It comes up to this hole. It comes out, and depending on which way you have your bearing in there, let's see, there's the little tip. Okay, so our crankshaft is going this way, so that oil is probably coming up here. It's getting forced in between the journal through these little pads here, and then it's being forced into the crankshaft, into this hole, which feeds it to the connecting rods. This is why when you have a low oil pressure situation, now at idle, you're going to find you have low oil pressure. Well, there's not a lot of load on the bearings, and it's not turning real hard. When you're going a constant speed, everything sort of centers up, and hopefully, you know, you've got good pressure, everything's round, it's balanced, it's working the way it's supposed to. Your little bit of foreign matter that does come through could get into the bearing and prevent you from scratching up your crankshaft. Matter of fact, let's look at this one over here. The reason why I went with that 2020 crank instead of this 1010 is because of that very reason. Could you take my word for it? Can you see through the plastic here? I don't want to take this all out. I've just got one hand, but there was just a few little marks in there. And I thought, well, you know what? This one's balanced. It's got the counterweights. It's going to be just a stock cam, not going to be spinning wild RPM. I think I'll just go ahead and go with this. So that's why I decided to go with this particular setup, and it's already been professionally balanced, and I have the flywheel that's balanced to this crankshaft as well. So yeah, happy camper. Happy camper. So we've covered a lot of stuff today. This is why, in addition to not having the window of time to work on it, I'm also perplexed with deciding I have a lot of choices here. If I was spending my money, you know, I don't think I would have gone with the CB 22 gram lighter lifters. I'm sure they are excellent. I might save those and go with that on the cheater cam and go with a little bit heavier duty springs. But for right now in this build, I want to try a stock cam with reground stock Volkswagen lifters. And these lifters are, this is the set I bought. And I'm pleased at the grinding job they did there. That's just dust on the top of it. I don't want to take it all off and have them rust, but 97 in stock. These are 86. These are going to be 10 grams lighter than the stock ones. I'll use the light push rods, and we're going to be good to go here, and we're going to have ourselves fun once we start building it. I still am doing some fitting and grinding. I thought possibly while I had this case is dry and clean. It's not clean as it's going to be before I put it together, but I thought that I would maybe drill and tap it for a full flow oil system. I have no intentions of putting it on. I'll just put a plug in there, but I wanted to show you guys how I do that. Last minute news flash. Here I ramble on and on about all these little spacers here to put underneath your valve springs. Well, on heavy duty valve springs, I think I mentioned how it prevents chafing of the cylinder head and keeps all that aluminum from getting worked through the system. You've got your steel insert that goes in the bottom. But what I forgot to mention, for every 40 thousandths that you add, you're adding about 5 to 10 pounds of spring pressure just for that small amount. So if you have an older engine and the springs are getting weaker, sometimes you can kick that spring pressure back up by adding these shims. You probably, if you're using a stock cam, you're not going to be in danger of coil bind, but it's always a good thing to check so that you know. Coil bind is when your valve is fully open. In other words, it's being compressed, that these springs don't touch each other, because if that happens, something's going to break. Something's going to bend or break. And so you don't want to get carried away with these things. Try one and see what it does. And if you have got healthy springs and you add one of these, there's a chance that extra 5 pounds or 10 pounds might give you a couple hundred more RPM over the other guy. So it just, it's good for the engine. That spring pressure will help things, help that valve track the camshaft. So, you know, sorry I didn't put that in at the appropriate time, but you know, when all is said and done, there's a lot more being said than done. Thanks for watching. Thanks for subbing. TheEZGZ out.